Hey everyone, welcome to this explainer. So if you're building or maintaining applications on XOOPS, which is pronounced Zoops by the way, you already know that performance is, well, it's literally everything, right? Today, we're diving into XOOPS DebugBar 1.4.0. We're going to see how it completely flips the script on tracking down bottlenecks, turning what used to be a pretty frustrating guessing game into highly targeted precision telemetry.
We've all felt the pain of blind optimization. You've got a slow page, but where exactly is it losing time? Is it getting bogged down in the system bootstrap? Is it a tangled web of app logic? Or is some runaway database query just completely choking your resources? Honestly, without the right data, trying to fix performance issues is kind of like trying to fix an airplane engine while you're currently flying the plane. Not a great idea.
And that is exactly where version 1.4.0 steps in. It introduces this incredibly pristine, interconnected layout of data layers to really illuminate your system flows. It gives you precision tracing and actionable granularity, which is basically a fancy way of saying it filters out all the background noise so you see exactly what you need to see. Think of it like a transparent, high-fidelity diagnostic membrane that's laid right over your runtime environment.
So here's what we're looking at today. First, granular time splits. Then, real user web vitals. Third, unmasking N+1 queries. Fourth, we'll check out XDebug and asset scanning. And finally, number 5, we'll wrap it all into the ultimate developer workflow. Let's get right into it.
All right, Section 1, Granular Time Splits. Let's break down boot, SQL, and app times. Now, this is a real game changer. Version 1.4.0 introduces a definitive boot, SQL, and app time split. Why does this matter? Because by isolating exactly which segment dominated the request, you know right away where to direct your focus. Like, if your app time is spiking off the charts, spending hours tuning your SQL queries isn't going to help you at all. This granular data is now reported directly in the performance panel, and it's even broadcast via server timing headers straight to your browser.
And you know, this precision actually extends right out to your front-end rendering too. DebugBar 1.4.0 introduces a per-request block cache split. Picture a front-page rendering, say 19 uncached blocks. That means you are paying the performance tax for 19 separate renders on every single page view. No thank you. Now you get cached versus uncached block averages aggregated straight into your analytics table, making it super easy to spot exactly which blocks are just burning through your server time.
Moving right along to Section 2, Real User Web Vitals. Let's talk about actual field performance.
Okay, so we now have real user monitoring, or RUM. There's this incredibly lightweight script that collects field web vitals directly in your visitor's browser. It's measuring things like largest contentful paint, interaction to next paint, and cumulative layout shift. It then securely posts these back via a beacon endpoint and attaches them directly to your stored profile. So you aren't just guessing how fast a page should be in some perfect lab setting anymore. You're seeing exactly how fast it actually is out in the real world, complete with clear, color-coded thresholds.
Next up, Section 3. Unmasking N+1 queries with the brand new Query Fingerprinter.
So in the past, your system might just throw a warning that, hey, 60 identical statements just ran, leaving you to manually hunt them all down. Well, 1.4.0 introduces the Query Fingerprinter. What it does is normalize statements so that structurally identical queries, the ones that only differ in their literal values, are mathematically grouped together for analysis. This is huge. It takes this chaotic list of hundreds of queries and transforms it into a super clean, prioritized leaderboard of your worst repeat offenders. Seriously, it's the end of pulling your hair out over N+1 loops.
But look, finding the duplicate query is really only half the battle, right? You still need precise attribution, and 1.4.0 is super smart about this. It intelligently drops all those generic framework layers, like database drivers and generic loggers, that are literally never the actual problem, and it hands you a perfectly trimmed backtrace. It points you directly to the offending file and line number, so you instantly know, those 62 executions came directly from itemhandler.php on line 255. Boom, done.
All right, Section 4, XDebug and asset scanning. Time to look at deep diagnostic profiles.
Here's where we see the whole workflow connect just beautifully. On the macro level, you spot a slow module using the analytics table. Once you've got it isolated, you can trigger a one-shot XDebug trace. Then, using the built-in profile viewer, you parse that cache-grinned output, which lists the creator, the total cost, and a full top functions breakdown. So you can literally go from, hey, this module's generally slow, straight down to the exact expensive function call, entirely without ever leaving the control panel. On top of that, there's the new Asset Scanner, which acts as an automated background auditor. Honestly, have you ever accidentally loaded 2 different versions of jQuery, or maybe multiple Alpine JS runtimes on the exact same page? It happens to the best of us. The Asset Scanner actually scans the rendered HTML, sums up your local asset sizes, and immediately flags any of those budget-violating duplicated scripts. It writes those findings straight to the stored profile, meaning you catch front-end bloat way before it ever hits production.
Which brings us to Section 5, the Developer Workflow Methodology.
When you run into a performance bottleneck today, you just don't have to guess anymore. You follow a really logical, evidence-based approach. Step 1. Check the field vitals from your actual users to confirm there's a pain point. Step 2. Isolate the macro time split to see if you're dealing with a boot, SQL, or app issue. And Step 3. Use those call site backtraces or Xdebug profiles to trace the problem all the way down to the exact line of code.
And the best part? While you're going through this workflow, DebugBar ensures your environment stays completely secure. This read-only diagnostic snapshot confirms your runtime health, active themes, and writable storage. Crucially, the whole system is designed to fail closed. So anonymous visitors? They never see any of this. Plus, all diagnostics are heavily sanitized, so things like session IDs or tokens are never leaked to the UI. It's just a pristine, highly secure observation deck.
Upgrading to 1.4.0, it really isn't just a minor incremental update. It's a fundamental shift in visibility. By stripping away all that noise and giving you clean, fingerprinted, and attributed data, the power is entirely back in your hands. So with all these layers of telemetry finally transparent, what application bottleneck are you going to eliminate today? Thanks so much for joining me on this explainer, and hey, happy debugging.